be looking at how we can prove the trigonometric identity sine squared theta plus cos squared theta equals 1 using the Pythagoras theorem. So here we have a right angled triangle ABC, and this is our reference angle theta, and this side is opposite the angle, so this is the opposite side. This side is opposite the right angle, so this is the hypotenuse, and this side is adjacent to this angle. Now remember from our video SOHCAHTOA, which we said the SO is an acronym to represent the sine function being as opposite over hypotenuse, and the cosine function as adjacent over hypotenuse, and the tangent function as being opposite over adjacent. Remember, Pythagoras theorem states that the square of the hypotenuse is equal to the square of the adjacent plus the square of the opposite. So the square of this side is equal to the sum of the square of this side plus the square of this side. Now let's use letters to represent the hypotenuse, the adjacent, and the opposite. So H is representing the hypotenuse, A is representing adjacent, and O is representing the opposite. So H square equals A square plus O square, where H is the hypotenuse, O is opposite, and A is adjacent. So H square equals A square plus O square. If we go ahead and divide both sides of this equation by H square, the hypotenuse squared, we're going to have H square over H square equals A square over H squared plus O square over H square. Now note that A square is equal to A times A, and O square is equal to O times O, and H square is equal to H times H. So H square cancel H square, you have 1, and A square times A square, sorry, A times A over H times H for A square over H square, and O times O over H times H for O square over H square. So now if we go ahead and separate this out, we have A over H multiplied by A over H plus O over H multiplied by O over H equals 1. And now remember that SO tells us that sine theta is equal to opposite over hypotenuse. So instead of having O over H multiplied by O over H here, we can change this O over H to sine theta multiplied by sine theta, because O over H is sine theta, opposite over hypotenuse. And instead of having A over H multiplied by A over H, which is adjacent over hypotenuse, we know that from cos theta is equal to adjacent over hypotenuse. So we can replace A over H with cos theta. So A over H multiplying A over H will be cos theta multiplying by cos theta. And then we have plus sine theta multiplied by sine theta equals 1. Now cos theta multiplied by cos theta is cos squared theta, and sine theta multiplied by sine theta is sine squared theta. So we have 1 equals cos squared theta plus sine squared theta. So sine squared theta plus cos squared theta equals 1. If we change, just reverse this. So here, this is how to prove that sine squared theta plus cos squared theta equals 1, and it's very important to know how to prove this, as this is very useful in solving so many trigonometric identities.